Hello, and welcome to another not another website, another episode, another video about. I'm going to be working on Spider-Man again. So, what I have here is on the top now. Didn't realize you could do that in i3. Um, on the left here, we have Ghidra, which is kind of decompiler that the National Security Agency have released under open source. And what I'm doing is kind of stepping through a particular function that I just kind of marked as checks unknown 2 bytes. That's kind of what I did in my kind of first initial pass. I was more interested in the decompressed one, which I have kind of gone through and done a lot more annotating and whatnot. But in the checks unknown twos function, I hadn't actually done that much annotation in it to try and work out what it was doing. I just was like, this looks like kind of some unknown 2 bits, I'll just stop there. So what I've done is this file here, notes, is kind of just kind of my raw dumping of what's happening here, and when I get a meaningful comment, I'll kind of chuck it up in here. Otherwise, this is just kind of my thoughts of what's happening so far. And so I've got basically a bunch of stuff. We do, let's find the start. We do a bunch of stuff at the start. I've also got an address here that this is the address that is kind of the unpacked address, I think, that appears in if you run it under DOSBox with debugger or DOSBox X, etc. You can use the debugger and kind of break at that point, and you'll be dumped into this function, which can be kind of handy sometimes, maybe. But yeah, so what it does is it basically gets some stuff and stores it in basically variables. These are like just memory addresses. I guess you could make that clearer for more C style. So it kind of assumes that SI is going to be a room pointer, pointing at some room object that it has decompressed from the rooms.sbl file, which I have managed to do that part. So I've got like a bunch of room data, and some of it is unknown so far. Like I haven't really given it a meaningful tag. And that's what I kind of want to try and work out what is happening. And so what happens here, we set a bunch of things. We have some counter-like things. We have maybe what looks like an address or something like that. And then we get some data out of the actual room file. And then we move the pointer of the rooms object to be now pointing at rest. And so here we kind of have an if statement. So we can kind of see that this is what is happening in the assembly. If you kind of study the assembly line by line, you can kind of see that's what's happening. And we have this test and in J and Z. And so that is this whether it is not equal or equal to 0. So if it's not equal to 0, it will jump to this thing, and this is just going to be after a big loop. So it will do loop CX, and if we go there, we can see we're just down from the loop. So what we do here is we like initialize a loop. Well, we already kind of have the loop. It's just unknown to I. We just make sure that CH is clear because we haven't actually used it thus far. And so have a drink and get And then what we do here is we do a big loop, as I kind of suggested. And if we, how do we? That's not what I wanted. You can go away, but we can kind of go back. And if we look at this arrow, the white line, it's an arrow, but it looks like a line at the moment. If we look at that, we can kind of see what's happening. I might get rid of that and this and this and this, just to give a bit more real estate to the screen. I don't know if the font's that good because I normally have it that sort of thing, but I don't know how to do font. Font. Oh, this is like in the other tool, which I have somewhere here. You have to do things in a different way. Nah, I don't know. Ghidra is a bit weird. I mean, it's used to do a thing, and the NSA, I'm sure, used it very extensively. It is a reasonably well polished thing for what it does, but it does have some oddities to it, which you wouldn't see in like different genre of release software, I guess. But yeah. So, in the big loop that we do here, we do a big loop over the second bit in the unknown2 array, which has to be not equal to 0. And that's a kind of key point I want to maybe... so if we look at this, and so we normally kind of look at the... I don't want that. I kind of want that, yeah. And then I can see where you can't see. If we look at this, this is just the first level, midnight. The second bit in unknown2 is 0, so this code wouldn't do anything. So it doesn't really deal with most of the leftover data. But if we look at 2, I guess, we can see that it does have indeed a bit. So what this will do is we'll loop twice, looking at something. And so maybe we'll try and work out what these things are. And so what it will do is it will read kind of two things. So SI was the rest that we decided. Well, not decided, that we worked out. Well, that I worked out. And I'm now kind of describing to you. So we get 2 bytes, and then we do stuff based on that. But we also store it in kind of a structure that's kind of getting built up, where we are setting like... we're setting certain bytes in certain places in that structure, and then we like mask them in different ways. It's kind of an odd thing, but that's what it is. So what happens if AH and H0 not equal to 0? And if we get to this window, we can see the first byte has a 9 in it. So this is going to fire the other one. So I wonder if there is a better test case, because I've kind of made an English, well, not a more like pseudocode type thing here, which it says things a bit more concisely than this, where like that if statement is taking up like more or just over a screen full of things. But I guess we could go through the second function, which actually just calls a function. So if we look at that function, we can see it does a lot of things. I've kind of written out vague stuff, but what I might do is kind of take this and kind of annotate it as we go down line by line. Fun. And then we can then move up to this file and kind of write it out in full there, because the first kind of thing it does is it does adds 0x32 to the base pointer. So I'm guessing this is kind of it gives us a few clues. So I actually noted at the start of at the start of here, that if that second thing is not 0, then we kind of set a thing that is like just 16 bytes after one pointer. So this is going to take up 16 bytes, or something like that. I think that's kind of what it's implying, which we could kind of overrun, which is kind of interesting. But yeah, so this is kind of pointing at this, but how long does it go for? I mean, it could go for a while. It does a few different type loops. But in here, this function kind of adds 0x32 to the base pointer. So what happens when you call a function? So we have actually called a function here. We go call, and it called the function. So we can actually maybe come here. Can we go like this? Yeah. So, like, call x86, something like this. This one here. So, what it does, depending on what it does, we will be like the near call, I think. So this is like EIP, but we're only going to look at the IP. This is like way too many words. Like, is there just a... that's also just too much. In essence, what it does is it pushes the address that you're at and the current base pointer onto the stack. So I'm wondering that when we do this, and then it kind of offsets this, what we're doing here is we're saying that this is using stuff from either that one or that one. We could fire up a debugger and see which way it's going and just try and work that out. But otherwise, we can kind of just work out what things go as they go. So started at 0x01, so it's like a word. That's all right. Can we make that a different? So 0x9293 added as that, just so we kind of know what's happening. And so it stores some more stuff in that structure that we kind of had. So we could potentially copy this, but maybe here's what I want. And yeah, so here when we set DI and do some things, maybe at this point here, I don't know. So this nothing we have now set to be temp AX. So it's really going to be I think the same as kind of last time. So it's going to be rest 0 and 0x1f, and 2 is just going to be the next byte up, and that's because that's just the way the cookie crumbles. AX, well, H, and AL were read to like way down here, so we know that's what those two values were. In fact, I think it might be in that comment I copied. Yeah, it was, but we don't really need that anymore because it could be incorrect. It most likely is. Right, and we also have 5 to 6 because this is going to be like base pointer. So we say what it was, 0x9 to BA. Was that something that happened in the debugger, that comment that I wrote there, past here? Maybe it was this. Right, and so what do we do here? So try and keep these roughly in sync. So we do that thing, and then we get like some stuff from the base pointer. Is here, like, what's this? Is that just like a variable for this? I guess, yeah, it might be. Right, where do we pop this? Gosh, all the way down there. So that is kind of where we're dealing with this temp AX. So that's doing that. We're adding on whatever was pointing at BX. So like BX is kind of interesting. What do we use BX for in here? We kind of read it as like it's maybe like pixel data, because I noticed in this we had like a kind of tightish loop of reading stuff, but it did some other stuff first, maybe. Right, so yeah, we add on that whatever we read from there. The joys of assembly. I can just hear my laptop wearing away. Probably means I'm not talking enough. That's, I don't know, sometimes a little tricky to stay focused on what it's all doing, I guess. So we add those two things, and then we're doing some stuff. We don't, so DO, we say it's first, and that, yeah. and times 8, and that is because we add it to itself once, so times 2, then times 4, then times 8. They could have shifted, but they did adds instead. Don't know. And then CBW, I actually had to look this one up. It's like sign extend. So it's like change from byte to word, I guess. Maybe that will help me remember. It's meant to be mnemonics, and I guess that could be what it is. Because it is changing AL to basically a word, depending on whether it has the sign bit there or not. Which is kind of interesting because we're a AX got an and there, but then we add stuff to it, yeah. We add those two things. So it could have overflown. But it's kind of interesting because it kind of just drops the BX1. Well, like, yeah, the BX just doesn't really matter. There it is, because I guess we move it to DL. So DL, this is wrong, I think. No, that is correct. So that would be from all the way out there. Yep, and then times that. So BX1 weirdly dropped there. And actually no, it's BX0 would be dropped. Not 1, because it's the one that is getting sign extended into the upper. Well, like the whole thing, just so this would be rest 0 plus BX8, BX0, that's dropped. But then this, I guess, is rest 1 plus BX1. But the rest 1 is actually also ended with 1F. Is that correct? So we we end it with all 1F, and then we add on the things. And then we do another times by 8, 2, 4, 8. Then what do we do? So we're doing this, and where'd that pop end up? Pop, pop, pop. That's where my temp AX should stop being used. Right, so now I'm talking about BX. So BO. Oh gosh, this is cursed. So while BX is being used, so it'll dereference BX, and then it'll add 2 to it, and then it'll dereference that memory address, read a byte from it, and then move that to BL, which will, in essence, change what BX means. But that's kind of interesting using it at the same time. It works, but it's a little odd. And then we like end it with that. Now this is perhaps need to put that there. We don't really, but what do we use in terms of base pointer? I kind of want to DP this. I might just call this bars, and then makes it a little standier, outier than BX. But yeah, where was I? Bars. No, this bars. Just had a wee twinge in my neck. Alright, so that equals that, and then we double it, then we clear off the top half. Now, what's this A9E3? So, first off, A9E3, do we use it in places? So we use it in like two places, once there and once there, but that's me kind of spelling it out, I think. Interesting. Yeah, don't really know what the constant is. It's just a weird constant. And it's like reasonably high, like it's a kind of like it's a memory address, but we don't have it. Like it's not in any of the things that we set up. It might be used further down because I haven't really gone beyond this. Could be heaps more stuff. What was that? What was this one? So, then what do I think? So it's just a random thing, all right. But we read from it. So yeah. Where is this? It's just a pointer. Is that actually no? Chrome. Let me bring you there. VGA memory. Yeah, memory map actually. That might tell me. This is not the right one. This is like the um, yeah. So I guess this. Yeah, so these will be kind of getting met. So if it's at least 64K, I guess, um, might be in EGA RAM. Another thing we can do is if we go back, oh gosh, can we go back to, yeah, this should be good. And we can search for like A9, A3, like any of these kind of using. We can also do like a search, which your mileage varies. Is it just we go like that? Yeah. So if we search for well, I mean it gets it there. So it will have to be E3A9, E3A9. Um, Surely it found that. Do we do oh E3A9? Oh, so it is. Yeah, it is reversing. I see. I see. Um, cool. So there's something here, and uh, this function, 3EFA, which I think we're talking about in here, 3EFA. Yeah, and that'll be where I did mention it. What was my other search? Yeah, so that's like in the middle of that. What's this? 3F86. It's nothing like useful close by, so it's the awkward. Oh, this has like a printing type thing there. But I think I'm happy with that. Is just a certain position on the screen, which I could potentially work out based on where it is. Because, yeah, I guess yeah, but we won't be here. So, if it was the case, it starts at A000. So it would be like 900 and it it stores it as like certain values. I can't recall how it's stored. But yeah, it looks like it's poking in the middle of it. So this probably reads from memory, which seems real expensive. Maybe it's not. But what do we do with it? We subtract 10, which seems like it's doing a hex to binary conversion, likely to display to a user. And there are places on if we spawn this up, and it'll just take 10 years to actually start. there are places on the screen that it displays numbers. So look at it go. It's just like high speeds of DOS. Once we're in. So yeah, we do have like numbers that we kind of get to the binary case, the decimal case, which is kind of handy. So this could be getting current thing. Nah, it doesn't quite make sense though, does it? Because then I just don't know. Um, right. So we still do all of this stuff. So CH would have got set. So this, well, we could make it a bit clearer. It's just CL, and that one was CH. That kind of makes sense. So we can kind of see what's happening in this vase thing, which makes me wonder whether it is. Um, um, Pointing at our like out struct that I kind of had up, potentially not in here actually, in this one. Yeah, this out. I wonder if it's potentially pointing to that, with the shifting of the BP. Could be, could be. Right. So what do we do there? And we subtract 10 off and all, but could be anything. Could be like we're giving a number. Like there's any sort of reasons, but it's got a certain smell to it. Um, right, so then we get AX again. So is this back to the original? Where do we go? Yeah, so we are back to the AX being its own thing. And so we do a similar flag to the other version. Well, actually, the other version did. I might have changed it, but yeah, it's kind of like a 6C shifted down by 5, which could do that. Because now it's only shifting it by 2. Hmm. And this doesn't seem right. So it shifts right by 2. That's all right. But then there's AH. So if we or AL with AH, I feel like it should be that. and we can do some things. So if we look at, say, the binary of this, we can see that we've got what 4, then another 4. So it's pretty much ending on this, and then this goes 4, then another 3, and imagine there's another 0 in between there. But what we're doing is we're masking it with this, so we're only going to have these particular bits, but we're shifting it right by 2, something like that. And so what this is doing is it's kind of bringing some stuff in. And so what I wonder is, what happens if we do something like this? We need a 0. Sorry, buddy. We only get 3 things there. So what I was wondering was, in this one, we have 4 there, then 2 1s. That would be easier if I turned off mouse to get into this for some reason. Basically, that's your 1 byte, and then that's your next one. So you have 3 bits. So they're kind of looking at the same part. So I guess if we're ORing them together, that is just ensuring that we're always going to get. Well, AH was the one that had only 2 bits, but yeah, we basically end up with 3 bits, but we could get a bit that wasn't there. Some interesting bit things. I'm kind of interested in what this might be in hex as well. It's almost. It's almost. So you might have something. You might have your first thing. Can we do that? Yeah. It's kind of like you have rest 0. And you can have it divided by 4. So each time you shift right, you're dividing by 2, and each time you shift left, you're multiplying by 2. So if we had that, so it's basically this, but I guess with this one was 1/8. And all of that, or rest 1 divided by 4. And this one can be 3/8. Yeah. Basically, it's that. which is kind of a weird little thing. And then it's like kind of getting added on. So before I had it set AH equals 0, I don't know why I said that. I think I skipped some steps before I did that. Right, so we get this, and then we shift it right, and then we do this OR thing, and then we. Oh, this is only shifting that right. But that's all right. So I think I can kind of rewrite this as rest there. And what was it? 1-8. And then this rest 1 isn't getting divided by anything. And it's just EO. So I wonder, what is 0x1H and or E0, is that all 5? Yeah, so that's selecting the just top 5 bits of those two things. Cool. I think I wanted that. But yeah, we do that one anyway. And then this is then getting shifted right. AKA divided by 4. 2, 4. 2 shift rights. Golly. And I wonder if we can potentially even rewrite it as not 4, 2. We can gosh, that one divided by 16 and 6. Just to make the code that I write eventually a lot saner. And what would that be? EO. That was just 3-8, wasn't it? E8. Then we didn't need that. Cool. So it's really just that. in the end of the day, if I'm not mistaken. So we might have 2 bytes. So maybe we can say b equals, I don't know. We can helpfully make it so this is, well, I don't know. So my logic is we originally got the first one, and we'll get a byte and we're going to end it with 60. So the byte is going to be that in essence. We're going to shift it right twice. And the output of that, I pushed that thing. Ooh, yeah, that looks good. Now there's like still another thing attached to it there. I don't know where I chucked it. Was there a thing to kill clients? I don't know. Maybe it's just going to be like this. Yeah, I don't know where it would have ended up. I'll have a quick hunt. No. Oh yeah, that's it. So you can detach, and then you can come back here. Right. Right. So basically, our first byte is going to have this, and so this is basically what's going to get stored in rests AH. So it's going to be that's going to be the mask, whatever we apply. And the thing that we get is going to be divided by 4. So keep that in mind. But then the next thing is we're gonna like do the OR thing. So we will have something like EO, and it's just that's what it's going to be. And then we shift that right another 2, and we get a 3E. Does that make sense? Can we like do a weird double at the end? I think I might have to do the weird thing that they do. Well, maybe I'll try and step it up again. So it's going to be rest 1. We're going to have rest 1, and it is going to be EO. And we're going to take this and OR on. Maybe we'll do that in that order. We're going to OR on rest 0 and 18. And then that's just going to be that result. Easy. And then this whole thing we're going to divide by 2. So I think, yeah, the 1H and E O, which will need 0x's, will just be F8. And so that's not really losing any information, right? Um, so really it's this F8 thing shifted more, but I think we do have to split it up into the component parts. So it would be series 1H shifted again twice. So that would be the 16, and then the divided by 16 would just be the divided by uh, divided by 4. This thing is divided by 4. Yeah, so it just divides it by another 4, that whole thing, and then ends it with a slightly smaller thing, because we're only looking at the top bit, so it's like, yeah, kind of works out. And in the end, we should have something that's kind of ends up like that, I guess. Is that what I mean? No, we're only doing another 2 times, so we'll just end up with F, which is like the bottom 4 bits. So from those bits, are we losing anything? So bin of 60 is two bits, and here we have 5 bits, 3 bits, so we'll have 5 more. So we do kind of lose stuff when we go to this, only 4 bits. So is it on purpose that a bit is lost, or am I missing something? We do like an add, so we double that whole result. Yeah, I guess like one of these individually will kind of lose stuff. Is that what I'm seeing? No, that doesn't. And EO shouldn't either. Oh, only one we're doing twice, right? Yeah, so this we're only doing once. And that would be twice. And so what is all of this? That looks good. So that's still selecting just 5 bits. And So, and now is that right? What I'm looking at, EO2, that's the 38, and the 60 to 4, that's the 6. Yeah, so I think that's right. And then we're like doubling it, which in essence is just shifting all of this back up by 1. Yeah, so this, if we no, make it, I'm gonna get out the keyboard stuff. If we shift it up by just 1, we double it, and we can see that that's the same as just doing the multiply by 2, or in essence, it's trickier. You can do something like this and copy the whole thing. But yeah, so 7C. This is what the whole thing is going to be. But no, I just want the component parts really. So I just want hex of 0x60, just 3. So that's C, and EO just to 1. So that's 70. I suppose now that I think about it, I already knew the component parts. Right, so this 60, that is going to be a C. And so it's going to get multiplied by 2, so that's just going to be an 8 there. And this is going to be a 2. And this 3, 8 is going to be a 70. Is that right? Yeah, 3, 8 is half of 70. I was like, that's not half of 70, but it is in hexadecimal. Cool. And so now we don't need that 2 times. We've just done the whole thing. So we can just say that's what that is. Makes it a little easier to kind of see. Right, and then we're like bxing, adding that, and then reading some stuff from bx. Let's kind of bring this up again, because we'd already read some things from that and stored in that. But we reset. Yeah, we popped AX, so now we're kind of doing that. But that was when we did a little read from BX. But that must only happen if like a certain thing. Nah, there's like no jumps in this, which is kind of interesting. But yeah, anyway, so now we read from BX3. So before it was just BX, but now we may have added like a bunch more stuff. So now we're like at a different point in that. I don't know. VGA RAM again. It kind of seems like it might be pointing to just variables. We didn't really change the DS though, did we? Yeah, the DS seems to be the same. If you change like one of the DS or CS or ES, it changes where you read stuff from. So I was wondering whether, like when it's reading from the A9 whatevs, whether it had changed meaning from the A9 up above, I guess. But I don't know. I think I'm sticking with my theory that it is just VGA RAM. So what do we do here? And can we slice it up? We are getting 2 more bytes from BX. So I guess we'd already read the 2 bytes there and kind of stored it in this vars thing. And here we're going to set some more stuff. So here we're going to set vars is going to be those 2 new bytes. And it ends with a 0. Interesting. Is it strange? Could be interesting to kind of look at stuff a bit closer. Right, and then we vars 10, we put that, and we'd already read from BX0, and we haven't really. Oh no, we do kind of do a BX equals BX. Yeah, so we read the pointer of BX, and we kind of store that, but like subtracting off 10, we store that in vars there. And then we increment BX. But this is BP plus 10. But that was 10 decimal. It's weird switching between. Alright, and then what's this fun for ED? It kind of looks like a little type thing from my code. So yeah, this is also kind of looking well into the base pointers. So it's kind of writing into stuff in this outside function. I feel like it's writing things here. Must be. Otherwise, like, what is it trying to do? Yeah, so this is just kind of moving stuff around. Bunch, and then while that times 80, that's just not equal to 80. Because we do a compare with 80, so if it is 80, it will loop out. So maybe we can say a thing there. This can be while AO equal so we can't really put it in the code, so but yeah. And that's really increment. Yeah, I suppose we could like even yeah, I suppose it's something like this. we could even kind of discard the thing, and while this not equal to do like nothing. Because we'll do it at least once. So we got to do the VX++, and we'll get the thing, we'll compare it, and then we'll see what it is. I mean, this is pseudocode, but it's kind of not quite even pseudocode. So, yeah. Kind of odd, this one. Let's just went to. That's kind of what I'm thinking. That is pointing to that. So it kind of like increments BX until. Yeah, so. What does it do? It sets 2.9 to theorix 2E. It's almost like a mem copy and stuff. And DX to. I really like long function names in there because then when you kind of go back, it might not show it all. But yeah, that's what that thing does. What's this other function do? So I guess that is. So we end function there, then we start a new function here. So in this is a little bigger from memory. Yeah, it's got a few things in it, and I think it even called another function at some point. Yeah, it called its own function as well. So yeah, it's kind of getting a bit long. Like it's still kind of unsure what it's trying to do and exactly where the memory is kind of getting set. And until that point is done, it's tricky to write the decompressor for it. But yeah, I mean, it's getting there. It's getting there. You got to do these like kind of hard yards to get to it. Anyway, what does this thing do? I'll go through this and see how I get, and hopefully by the end of the video, I'll have kind of this kind of bit kind of annotated and kind of confirmed, because there were a couple of mistakes I guess I noted in some bits that I kind of made a lot smaller. In fact, I can make this kind of smaller as well, because I know that bars 1 is going to be this is going to be let's go back to it just to kind of confirm that's. Oh no, it's not there. It's like up here where it's doing the subs. Gotta hit the subs. So we sub that and then we add that to 3. No, but then we want this, so huh. All right, just wrote got 2 bytes from there. So this is really the BX. Yeah, in fact, I might just kind of get out of this mode thing and then that mode and then that mode. And yeah, I think I might kind of ramp this up a little as well because we can see here that, right. Yeah, we do some like curse things with BX. And like, where does BX start? Yeah, there's probably that thing there. I guess this is potentially looking. Yeah, it's kind of getting like an index based off the current, like, I think it's kind of like a pointer into the thing. It's hard to know. I guess what I could do is try and tweak some of the values. That this is all happening in cases where we have a thing that, well, I guess the BX, yeah, I guess we need a loop at least once, and the second level does kind of have that. We can also make our first level have that. We have like a little test level here. Do I have an easy way to edit the so there's a bunch of commands you can do, but you kind of need the address for it. Or it doesn't really say what values it takes, but I can look in room.c and it's like a patch instruction. Yeah, this patch instruction thing. Patches. So we allow certain things here. So I think we don't allow rest. So I wonder if I kind of maybe add rest to the. So we have name. So we can kind of strcmp rb. Kind of want an str in cmp rb 0, and this is going to be rest that, and we're going to say that's 5 characters, and if that is equal to 0, and we also want to say is digits are V0 and the fifth thing in it. And if that is the case, we will do a thing fairly similar to this thing here. Now it's kind of interesting. How do we like right room? Yeah, we do it right room, and we. Uh, all right. When do we call right room? I thought this was like. Right, so for all the patches and stuff. Right, so I think I need to have like a different thing if it is a thing. Oh no, yeah, we do allow this. That's allowing us a rest. And it does have an error if we have that. Where was it? Was it here? Yeah. So at this point here, we can say I think we can just say size of yeah, and it's start the compressed room. So this is going to point to the start of the rest, I guess. And here we can say the thing is going to be index long, and maybe this can be saying rest address and something like that. What would be good is a ways to have all of these things in an array type thing so that when I type help, I can see what my possible commands to go in here. At the moment, you just got to put it in manually. So did this have a make file? Yeah, it did have a make file because it's got a couple of things. So what I might want to do is, so if we do display maybe just one, I'll just play around with this lever, I guess. So we've got a bunch of stuff in our leftover data. What I might want to do is maybe what we go catch and rest. Well, I first want to go unknown 2, 1, and maybe make that unknown. There it's 60. Was that not what I wanted? We need a room ID. So we do something like that. We don't know that is STRCM. It wasn't in CMP, but can we do like case and simply case STR case CMP STR in right? So in this one, STR in CMP, this. I think I want case. I don't really want to bother around with whether I have a uppercase or lowercase type thing, if that makes sense. So if I go make right, we can't do that. The NCMP must come case NCMP, right? Find the N and then one C and put it there. Right, so now will it let me do that? So this is just spitting out stuff. But if we now display our room again, we should have 16 in there. And I wonder what it's going to have when we play this. So I'll boot it up. I might bump this over there. So we're not really caring about the assembly at the moment, and then we can kind of see that. We've kind of switched tacks to doing editor things, I guess. Maybe trying to see what's happening with the data. This potentially might crash as well. So I haven't seen any obvious difference. Yeah, no obvious difference, to be honest. So I don't know what. So that did like some loops over some things. But I note that leftover data doesn't have a certain thing here. Um, I don't know what I want to actually test with this, to be honest. I kind of want. Yeah, maybe I was trying to work out some things. Hard to know. Sometimes lose track of thoughts. Yeah, I guess we're like changing BX here. Does it actually change? We do a push BX, so it's like not altering the BX, I guess, in the sense that it will get reset, which I think I did have at the bottom. Reset BNX and CX. Right, so I guess what is this BX meant to look like? It's meant to be like A9E3 plus some stuff. And the stuff was BX2 and O7 times 2. So really, it's. I mean, we can just do that. And the BX2 was based on what unknown zero was. Um, and what is unknown zero? It's 1. So I like potentially if we make a large number. So say if we put 0 and 60, we can see these both starting with 0. And if I now leave it, that will hopefully show something different. I don't know. Sometimes the aim is just to get it to show something different, because then you know you've got something that you can kind of trace through maybe in a debugger to see what's happening. sometimes, I don't know, you just gotta kind of go with what's what. Yeah, so this looks the same. Yeah, same. Um, I know if you mess with the like rest data, you can get like different enemies to spawn and stuff. But that's kind of based on it's just fluking the decompression. But yeah, this is interesting. Um, right, let's try and kind of think through what things are here. Um, yeah, so we kind of say that we don't really care about that. That's all good. Um, Steam pegs get written back. Is this where we do that? Yeah, so we 246 AX. Do you ever get changed? Nah, so this is adding the original stuff up here. So what is this looking like? This is looking like rest 1 and 1F plus BX 1. All shifted that way to 4, 8, 3 times. And here we like kind of overwrite what BX was. Um, we can say stuff like that. Sign extended, yeah, so it kind of got dropped. I don't know. And it's plus equal. Oh yeah, we already have that plus equal involved. It's interesting. Like if this overflows, it would like become. Yeah, I think that kind of does the thing that we want. So we can kind of maybe kind of say that. Boom. That's just what it is. Um, and that comment still kind of fits. So maybe we can say this is TPS. Maybe we can change it all up to RP. Come on. Here and do it G next. Yeah, and bring me back to here. Yeah, it's kind of interesting. It doesn't seem like it's pointed to RAM. It kind of seems like it's meant to structure, because we're kind of getting certain things out in certain order. And we're also applying it as a pointer to a pointer. So this element is a pointer. Yeah, and that just increments until we get to something that isn't an 8-0. Um, hmm. Now, is that the way that it kind of did it? So we'll increment bx, so we will at least test it. So afterwards it will be incremented. So it will be 1 after 0x80. Temp bx is between 1 byte after 0x80. So that's like a stop bit of types to tell it to go to the next thing, and then here it does some more things. What's this 9382? We didn't actually 9382. It's only used in this function. All right. All right. So there was this function here that we were starting to, yeah, so that's probably just a variable in the, so I guess. Wow, it's like a global variable, but that's just a if, not a loop. So yeah, here I guess the vase is still pointing to like 1 above, kind of like that other one that was doing it. Wasn't quite as explicit as how this added a bunch. Anyway, we'll get back to this one. Right, so in this, what do we do? We'll tidy that. Oh no, I think. Right, so we have that. We get our AX. This doesn't seem like what maybe I had already kind of shifted it up. Ah, go away. Um, yeah, I hadn't actually written more. Weird. I suppose this is just combining the two things, and then we undo that. I guess it's getting treated as a pointer type thing. and we didn't know where that was. Was that the case? Um, um, do, do, do. That's after we set the 14, 15. Yeah, cool. And so this is, maybe we can add a label for it. If BP 0x10 and 0x2 not equal to 0. Well, that's actually if equal after if not equal to 0, because that's what would happen if it is not equal to 0. It would do that sort of thing. Right, so now we just jump straight into another function. So after getting AL, so we kind of like, yeah, read a thing. What's this thing do? We could probably clean this up and say what it does. What's it doing? So this is not useful. So if this and 0x, I think that is what the test kind of does. So it applies a bitmap, and then if it's 0 or not, it's in essence just doing an AND, but not changing the value of AL. So what do we do here? We do like bizarre stuff. So here we're like swapping. If that low bit of AL is set, which AL was helpfully set to just something from our stack, if the low bit was set, so if it's like odd, I guess, then we do a swap on CX. So we do some things, and then we negate CH. Yeah. All right. Interesting. So then we go and test the next bit, I guess. So maybe this can get set to that. And so I guess these things are getting done if they're not equal to 0. Is that what I've got set? Yeah. And so there's like a particular thing that could happen there. So after this function, it's not a clear cut what it might be in terms of that, because it does apply a bit of logic. And what's this? AL, and 4. So it's just testing those bottom 3 bits of AL. So checks bottom tweaks CX based on bottom 3 bits of AL. I don't know, that can just be what I've called it. And then we can kind of see if it uses CX based on that. Like it doesn't really seem to kind of get things, but it now tests this, which is BP10, which wasn't the base pointer that we were looking at. But if we did that, then CX does some things. So CX is like bizarre. It could be a few things by this stage with passing. Right. It's nicer when it's just like a loop and you can kind of have a pre and post condition, but when you got a bunch of ifs, then like it doesn't really taste the do the trick. So this we can kind of say is BP 0. It's after that, and we're testing 1, and if it is 0, then we'll bounce, but if it's not 0, then we'll do a thing. Cool. Then we'll do a thing, we'll add BX to that. Yeah, I guess is, we can just call it red. We know it's not there. Well, I mean, it could be a bit nicer to keep in consistency. It's kind of interesting. It could have been done as a if else if thing, but it's done like an interesting thing that if it's not that, then it does like a few things in the middle. Then if it is that, then it does this. But yeah, where's it pulled this address from? A9E3, A9E3. So that's the same thing that kind of was getting pulled up from there, and we were pulling from it. No, we did we ever get? We were just pulling a token from it. But yeah, here it does a thing. So we get BP4. That's cool. Yeah, go away. Thanks. You just have to be somewhere in there. If this window is selected and you hover over a thing, it will like be nice with its windows. Might be a Java thing, I don't know. But if you're somewhere else and you hover over a thing, i3 will be like, oh, you need to open a window, and it opens up a non-floating one. And potentially I need to get the i3 config a little more fine-tuned. Right, so what is this doing? What is this doing? That's all good. Right, so we right, so we're getting that. I'm just saying it's like 1 byte. I suppose, yeah, because it will wrap around. Then we add on that thing, and then we see what's there. Then we get a thing from there. We add 10 to it. We add that to it. That's an interesting one. And then we add CH, which could be anything, Um, could be anything. Well, I guess it wouldn't be changed in this case, we know. Yeah, so the this and this and they're like not related. Like these two can't be the same. But in here, CX could have been changed to a whole number of things based on Vase 4, and Vase 4 got taken here. And so if we're timesing by 2, but then like it kind of means that we don't care about the top bit. But these don't really check the top bit, they just check the bottom 3 bits. And depending on that, will change things, I guess. Otherwise, what does this do? Right, so that's that whole thing. Then we do that. Then we take off the 10 again. Oh, it's weird that it like added it there, then like it is now subtracting it off again. So I guess here maybe AL is really buzz 3 plus 0xa and 0xf8. CH plus or that minus 0x a. We just minus it at the end. I mean, yeah, it's kind of a weird one that I wonder if we can kind of somehow eliminate these. But potentially not, because that's only got an 8, and there's still like a few bits that would. Nah, I'm not sure it kind of works. But maybe I'll do something like that, because that's just kind of my thinking at the time. And maybe I'll even put that there. Maybe change the vars to the VP, just because that's what it is in this, but in here I've changed it to vars. It's just because. What do we do then? We set that there, and then we get another 2 byte from. Oh no, yeah, there weren't a few branches. We literally get it there. So that is just that. Something like that. And then at the end, we will. It won't be deaf. Yeah, right. So we want to get it. Want to add that, and it would that, which we've kind of got there, then add CX to it. And so that's just both of these. I mean, in there, it's really that. Because this might overflow, I guess. It's getting a double. Well, a word. Then we like add some stuff. Yeah. So what do we have here? We really have. So it's going to be vase one. How do I want it? Because we're kind of like writing it back out. So I kind of want to say like combine that whole thing because like it's probably based on like a very simple statement. Really, this is getting some stuff and adding some things. So this is kind of only adding the one thing, but here we can kind of say AH is going to be it's going to be vase one, and potentially an overlap if that kind of causes vase two to overlap. But I'll just kind of ignore that for now. And then we can have temp bx 0. So that's going to be that. So we can have this go to 8. And AL is going to be similar, but without the shift. And here we're going to have that whole thing and F8. So, and F8. So 0, well, like 0x F8 plus 0x A. It does slightly overflow. Sorry, that was the wrong one. Yeah, so it goes over by 3 bytes if you were to kind of add a thing. It's kind of it's interesting, and I wonder if it is done on purpose to be like that, because really, this is also going to be vase 2. Is it vase at this point? Yeah, we've read from that, and this is going to be that. Or maybe it's I want it to be that. That's what AH is going to be. And then this is going to be that minus that plus so this is going to be plus the 10 bx 2 1 minus 0 xa. Yeah, I don't know. I don't know if I can kind of change it to not have that. It's a very similar kind of mask there. Maybe I can do something like this. And then it's quite similar to that one there. In fact, it's just gone up one index from each other, and it potentially could be useful when coding it up. And this just has like the weird if it overflows. If that overflows, which I don't know if that's like a specific case that they wanted to happen, and I don't know what base pointer 2 will have. So base pointer 2 should be like the thing that was so there'll be a thing that kind of calls come on. Yeah, actual real. So this whole thing. So we're not like pushing anything. So we do have the base pointer. So I guess we can kind of see whether things were based on that. I don't know. There'll be something. Gosh, we do a bunch there. Because we add like a bunch to the thing there. These are all like that. And there's like other stuff happening here. Lots more things happening here. This function might be interesting as well at some point. Hard to know if it is. Like it's doing a loop. It's moving stuff to this 97FE. Was that something that was here? 97FE? I guess not. It's frustrating. I don't have my other files. So this could be the VGA mode. I recall. that being a thing. Well, it's like after it checks for all your stuff. No, it's yeah. Let's check on that too. I don't know. What do we do? Kind of want to understand this function, give it a name, and then and most importantly, what do we use after it? So we're expecting 1e and 2f. We do, I don't know, so 1e and 2f. Do we ever kind of set that? Not too sure. What else does it do? Also, AO. Yeah, it doesn't really seem to use the values from here. So we have, we're just doing some setting at, I guess, some things. So the 3F, it'll set BP 1415. It'll set a lot of things in the base pointer. I guess what does it set? BP. We can have a look at what we have. So we have stuff at 26. This is going to be a thing. We have 1, 2, 3. 10, 12, 18. 10 again there. 10, 12, 18, 14, 15. 10, 12, 18, and was it a 14? Yeah, 14, 15. And then this, so 2, 9 to 2e. 2, 9, and it was 2e, and it's like kind of based off stuff. We also set stuff up here. 10 and 2f 3, 1. And we had 10 there. Then 0, 1, 2, 3, 4. And that's after doing the BP. 1, 2, 3, 4, 5, and 1E. 1, 2, 3, 4, 5, and 1E, was it? It was 1E. And like, is base pointer used any? What did I search for there? Cool. Right, what I might do is open that and buzz one. What does it say? That's not what I wanted. Right, 1D. This is equal to bx. Why do I have plus 30? Why do I have plus 30? Where is it? Get out of that. Just get into there. Get into there. We have plus 32, but then plus 30. That's bx. Bx. And bx. Bx. So it's none of that. Bx would have been something like set way back here. So that's the 150. It's going to be that, I think. Because, I don't know, if we get to this part and we do this, we will push a BX and pop it and then not set. And otherwise, all kind of, I don't know that. That's a different place. All right, yeah. So BX have we changed to? That was just like in the function. Yeah, so I think in this function we haven't changed BX, so BX is just kind of the original, which would be that one. Cool. And we set this like just as is. I haven't even got the comment there. So I don't know why this plus 30 is there. Just seems weird because it's not there. Right, so 1 EU, I use that again. I read it into temp BS. Well, in fact, I'm like resetting. Nah, this is like just before we reset. So we read an address from this. And this is like within a big loop. BX is going up by 3. Each big loop. It's a big loop. Goes all the way there. That's the temp BX, but yeah, so just every loop will go up uh, plus 3 each time starts at 150 plus known to 0. That's what it is. Right, now we set 5 to maybe we'll get it there. This gets just set to 5F. Maybe a couple more. All right, where are we at? 4 gets set to DX2 and 7. So this is this is the same BX. So this is going to be the second, like the next word up, but just one byte of it. That. By going through and doing this and trying to work out what the end structure is, we can potentially just do that in code and not bother with other things. But sometimes it does rely on reading to see where the memory needs to go to. Right, so vars 4, we just did that. Vars 3 DL, just on the how do we do that? That put it there. Right, so DL is going to be like it's gonna be like a pointer to A9 E3 plus BX2 and 7. Maybe 2 times this, because we do the 2 times that. And it's not going to be a pointer of there, it's going to be a pointer of the second one, actually. So this is going to be like there, and so maybe get it there and back. Right. Not that one. This. Right. Where do we next set? 1, 2, AX. So we could try and split it out into the two things because I think it is somewhat two separate things. Um, Now, see what is happening here. We are getting temp AX equals like this stuff up the top here. And then we add on just like a 1 byte. It kind of seems weird that we're adding on 1 byte, but then we're like dumping it out into a word. Not that one. So yeah, what is the 1 byte going to look like? So this is rest one. We've kind of just said it's this here. It's that whole thing. And then we're adding on CL. And is that correct that we're kind of adding on? So BP1 to 2 is like a thing. Um, yeah, yeah, no, yeah, BP1 to 2. So we're adding on CX, but we're like clearing out that. So it is as a where do I go? It is as a um, thing like that. I think that's the whole thing that it will be. And maybe I'll just kind of check where. So AX originally gets set. So we do this uh, extension. Um, I close this for now, just so I can see what's kind of happening. 2, 4, 8. So we're going to shift it 3 times, which is the same as doubling each time. So it will be at this point here. And so we're kind of excluding what a H was, which was BX, and only really caring about AL and just sign extending that. So it is just where do we get that? Oh, we get that there. Nah, I don't think this is that. Oh, we're like adding the, yeah. Yeah, so it's that plus that. Um, and that never gets added on. Cool. I think that's good. So maybe I'll get into that and open up the thing again. We can get to yeah, that one. This. All right, so 1 to 2 is going to look like a 2-digit number, and it is going to equal what was that? And that BX is this one. No, it's not that one because that's like after it's been that we first read it there. But then we read the second one from the second way. So this is from another location, which is this location. Yeah, really, it's just yanked in things. Really, it's just that. Are we for real? Yank to the end, and then um, is that right? Yeah, that seems right. It's it adds the thing and gets the thing. And here we're heading on CL, which is the one, whereas DL, which we put in 3, is the first one. So I think this is actually that. Small things. All right, so where do we next set things? 0 is just set to 4. Right, 2F. This was set to this thing, except that is a 3, and that is now 2, and that was still that. Cool. So we do that. Then 1, what do we get set here? This is going to be that. That's by here. That what I'm reading. With a temp BX. No, this is a different temp BX. So this is yeah. Let's change this to be uh, Right, so when we add on this, what are we adding? We're adding, gosh, this whole thing. All right, yeah, that thing, and do that. Right, yeah, hold that, and put it there as well. Need to work out what those addresses are, but that is what it is. Um, golly, these assembly things, they just take ages to kind of step through. I've been trying to think on like what is a kind of good way to do a video structure around this, but at the moment it's just me watching me kind of go through and work out things, and I go in a very roundabout order. Um, this temp BX is a different thing. So this is 292A. Does that make sense? No, that doesn't really make sense. 29 to 2A. Um, right, so let's close that. The where was I? When we call this function and it's in the middle of this, we increment temp bx a bunch, and then we so before that we do this. So 29 to, I guess, 2A does make sense. Yeah. Um, this thing. Right, so the 29 to 0 is 2A. This whole thing was going to be temp bx, but it's going to be the temp bx of the thing that we put in 10. Which this isn't going to be. Right. Is this, have we already put something in 0 to 10? Check it down there. We we only store it in the one place, and we just do a couple of checking things. Cool. Right. So in that case, this is not that. It is kind of this. It is first getting one and then getting another. And that was just getting the one byte of it. This 292A. So this is going to be this whole thing. We'll get the first thing, but then we'll get the next thing. So this will be 1 to 2. And so that 2A won't exist. In the 14, 15, we just can't really say what this is. This is two bytes after 0 to 80 after this. But after just getting one of them. That's what that is. Golly. So the 2B2C, this should be just bars 1, 2. And is this like in a loop? I don't think it kind of is. It sets bars 1, 2 to be the thing there. So it's kind of just recalling values back, I guess. So vars 1, 2 was just going to be the stuff here. And so we don't need 2C. 2D was going to be vars 3. So that can be that whole thing. And some things. And I think this is getting a little rare. So maybe I'll just do that. I'm not sure it like really makes things better, but it would make it a bit clearer. I did it slightly differently than vars 4. So this is just going to be that one there. Right. And then we just do a check of vars. We do a vars 14, 15. Is that what we? No, that's just what we did. So this 2.9. Is that the right one? That's the one we said was TBX. So it was that one plus 1. So we're looking at the 1 to 2 instead. And then we do the loop, and then 14, 15 should be that after. Yeah, after that thing. Weird. And then we based on AL4, we do some stuff. So that's going to be based on this BX2, which is based on like the whole loop BX. And then if this, yeah, and then vars 18 is going to be what, CX. But CX is kind of based on temp VX, which is based on the temp VX that got put in the 1415. But it's just 2 bytes after it. um, Based on 2 bytes after 0 to 14, 14 to 0 to 15, or 4, something like that. Then we have vars 12. This is kind of like the end pointer. End pointer after something like that. And I think that's filled out all of those, and hopefully that means we don't assign anymore. We do to 3, and it is based on a bunch of stuff, so it kind of gets updated, like it counts almost. There's some weird shenanigans going on there, and then this is pulling in 1 to 2, but then it's kind of setting it back to itself. So this also gets updated if the vars 1 and 0 1 equals 0. 1 makes if 0 is 10 and 0 is 1 equals 0. So that's what will happen. And what is this one that is doing? It's just like a chunk of memory. So it's, gosh, it kind of needs this stepping through a debugger. And what I could do is create a file that looks weird, and we can have it step through the debugger and see what is going on at each step, and maybe put some breaks and see the things go smoother. 26, we haven't actually marked that down because we didn't see it hiding amongst the edges. Right, so what does this get set to? This gets set to AL, which is gosh, it's either, so it's the one it's this thing here. So if oh no, this is like if star bx is yeah. So we're basically getting the value out of there, which should be our bx, and then if bx2 and there it's 80 equals 0, then we're going to have 0 on the spider. Otherwise, we're going to have the 2f1 and put that there. So something like that. And yeah, I think that is kind of what happens with the BP, but there's also the kind of what happens with the DI, the psi, and the uh, maybe something like that. Because DI is a thing that we need to kind of keep a track of. It had a nice little tight structure in here that we could kind of say what was set to, and then it then kind of got written in like a kind of loop type thing. And here we kind of do a similar type structure. And I think this not like increment. I thought this incremented. So when we do the call, when we do this call, we set a bunch of things in DI, but do we never like DI plus 7? Only right at the end. And so that's after we do, I assume that's this last little thing, and then we not that one, this one, we do a DI plus equals 7. So it'll probably be worthwhile to see what the DI is. But I think I'm not going to do it now because my brain is losing concentration on just staring at assembly. And I'm kind of going back and forth between multiple things, which isn't a good sign when it comes to things. But yeah, I think hopefully you've enjoyed watching it, and you can see some of the potential of what is happening next after don't like that, after we kind of get through this. This is like inner function, yeah. So after we kind of get through this and then go through there, and one more things. We would then do an increment, then do this, and then we'll be in the unknowns, and this chunk here, which would then have to work out, hey, what do all of these things do? And it's based on whether unknown 2 is divisible by, well, if it's divided by 4, if that divided by 4 is equal to 0, then it does. And I don't know, there's lots of things that you can do. There's a little knob there that was hiding. And this, I think, did have a call, which, yeah, you gotta kind of keep an eye out for the calls. It has another call there, and another there. So you just kind of have to dig deeper and deeper. And when you sit down, you don't know how deep you're gonna have to go. Okay. Thanks for watching anyway. Let me know what you think, and hopefully next time I'll have either something to show you, or we'll just go through and do this again and hopefully make more progress. But for now, thanks and have a great day, evening, morning, whatever it is, wherever you are. And I'll see you next time.